All right, we're taking a look at Aleks, lesson 2.4, number 1. Specifically, it says to multiply, and it gives us these two factors. It says, note this expression contains complex numbers. That's the imaginary. That's what complex is referring to, the imaginary. So something we talked about in class is that anytime you have an imaginary, there's going to always be one that's a positive I, one that's a negative I. That's because they always work in pairs. So when we multiply this out, what's going to happen are those i's are going to get canceled out. Now when I look up here, I have brackets and parentheses. I'm going to help myself out by trying to get rid of these inside parentheses by distributing the negative through on both of these parentheses. By the way, these come from the zeros. If this is factored form, the zeros would be, instead of a negative, a positive, 4 plus and minus 2i. So you take away this negative. If you set this equal to 0, you would take away the negative when the 4 plus 2i moves across the equal sign. And since I have a 4 plus and a 4 minus, that's why it's 4 plus and minus 2i. That's the imaginary zeros, or the complex zeros, if you will. That's where that comes from. But to solve this problem, let's do what it actually says to do. Well, let's multiply that negative through. So that means this first bracket is actually x minus 4 minus 2i, because I distribute that negative. And the second parenthesis will be x minus 4 plus 2i. And so whenever you do your first step, the only thing that should be different in the two factors is that one of the i's is negative, one of the i's is positive. And now we distribute through. So this is going to be a big time FOIL. So when I say FOIL, that's when we used to talk about first times first, outside times outside, inside times inside, last times last. But this has 3 terms, so it'll look a little bit longer. So we'll have x squared times negative 4. X times negative 4 is negative 4x. And then we'll have an x times positive 2i. And I'm going to use alphabetical order, so I'm going to say that's 2ix. And now I go to the next term, and the next term is a negative 4. So I'm going to distribute the negative 4 through. So I'll have another negative 4x. A negative 4 times a negative 4 is a positive 16. And I'll also have a negative 4 times a positive 2i, which is negative 8i. And now finally, last term, negative 2i, I distribute through, so I have negative 2ix. Negative 2i times a negative 4 is a positive 8i. And then I have a negative 2i times a positive 2i, which is going to be a negative 4i squared. Now the thing about i's, if I've worked out with complex correctly, the i's should cancel one another out. So for example, I have a positive 2ix and I have a negative 2ix. So these values would simplify one another, because a positive 2ix minus a 2ix leaves me with 0. So those disappear. As well as here, I have a negative 8i and then a positive 8i. These two would simplify with one another. Negative 8i plus 8i is 0, so those go away. The only I have remaining is this I squared over here. And so here's the deal with I. I comes from the idea of having a square root of a negative 1. So I squared would be the square of both sides. So if I squared both sides, I squared would equal square root of negative 1 squared, which would equal, those would simplify, negative 1. So to solve this, when I combine my like terms, I'm going to have x squared minus 4x plus 16 and minus 4 times, instead of I squared, I'm going to substitute in negative 1. So simplifying here, these two do not cancel one another out. They're both negative. So it's like I owe someone $4, I owe someone else $4, so I owe a total of $8. And then this is 16, and then this part right here becomes a positive 4 because you're multiplying. So it's 16 plus 4, which is 20. And this would be my solution here.